My algorithm was the VIR chart, and I will go through each of these steps and explain how to do each and every one. I'll also explain how I found every single value in every single slot of the VIR chart. I was assigned problem 44, and the question is, what is the current of the 3 ohm resistor? So the first step of the algorithm is to draw a vertical circuit. Since we know that this part of the circuit is in series and this part is in parallel, we can assume that this part goes first since it starts the battery and is before the 3 ohm resistor and the 6 ohm resistor, so we can put that up here. Since we know these are in parallel because they are quite literally parallel to themselves, we can make a new parallel section of the vertical circuit and draw each resistor on both sides. It doesn't matter where the 6 ohms and the 3 ohms are as long as you draw for both of them. The next step is find the equivalent resistance. Since we know this is in series, we don't have to do all of the other extra equation. We can just add this at the end. The hard part is the parallel circuit. So we have to take 3 to the negative 1 plus 6 to the negative 1 all to the negative 1, which is basically 1/3 plus 1/6 to the negative 1, or 1 divided by 1/3 plus 1/6. So as you can see, that's right here. And then you can't forget that we have to add, at the end, we have to add this because this is in series and these are in parallel, so this is a completely different equation to find the equivalent resistance. So once we've solved for all of this, we find that the equivalent resistance between the two parallel circuits is 2, and we add the 1 at the end and find that it's 3 ohms. So the total equivalent resistance is 3 ohms. The next step, and final step, is to draw a VIR chart. So the reason it's called a VIR chart is because it's V equals IR, and that's the equation we'll be using for the entire chart. Given all of the resistors values, I wrote them down right here. This being R1, this being R2, and this being R3. This is the same equivalent resistance that we found just a minute ago. So since we're trying to find this value right here, we take 12, the voltage, and divide it by the resistance 3, because V equals IR. This tells us that the current is 4 amps. So the total current of the entire battery is 4 amps. Next, we can find the current of R1 because in series the current is always the same. So this means that the current is automatically 4 amps. This tells us that the voltage of R1 is 4 because 4 times 1, or IR, equals the voltage of 4, or V. This also means that we can find R2 and R3, the voltage. This is because 12 volts is the total voltage drop, and the voltage drop that's not part of the parallel circuit is 4. So therefore we can take 12 minus 4 and find that it's 8. And since in a parallel circuit the voltage is the same, we know that both of these are 8. This helps us calculate the current for R2 and R3. This is because we already know V equals IR, so we take 8 divided by 3 and get 2.67 amps. And we get 8 divided by 6 and 1.33 amps. Now this proves that the answer is B because the current of this resistant of the second resistor is 2.67 amps. This means this is because we calculate it through V equals IR. So we know 8 divided by 3 is 2.67, and we just assume that they rounded in the question.